So welcome back. We are now going to go to part 2 of expressions of concentration. We'll be looking at milligram per ratio strength, milligram percent, and parts per million, parts per billion. So as I said before, we looked at percentage strength, and now we'll be looking at ratio strength. So let's determine what is ratio strength. We knew that percentage strength is speaking to the amount of a substance, whether it be a liquid or a solid, that's containing 100 parts of the whole. So now we're looking at ratio strength, and this is an expression of concentration that is going to be dealing with parts as well. It is a relationship between one quantity and another, and may be written as a common fraction or with a colon between two numbers. So you would have seen this when you went to primary school or in high school math, at least in first form, if my memory serves me right. So for example, 3 parts compared with 4 parts may be written as 3 to 4 or 3/4. The amount of the substance in the preparation expressed as a ratio is referred to as the ratio strength. Now, I don't want it to be confused with 3 to 4, where you're going to be adding the 4 and the 3 to get 7 parts. That's not how this works. It works by saying 3 parts out of 4 parts. An example of ratio strength expressed as 1 in 10 represents 1 part of the ingredient per 10 parts of the whole. So what it means is that out of a 10-part whole mixture, 1 part is going to be that ingredient. Generally speaking, ratio expressions are often written in the simplest possible form. So a ratio strength of 5 to 100 is correct, but it is normally written in the simplest form, which is 1 to 20. Of course, how did we get 1 to 20? Well, in order to express 5 to 100 in its simplest form, we have to divide the first number to be always 1. And in order to get 1 to be the first number before the colon, we'll have to divide that number by 5. Therefore, whatever you do to one side of the colon, you'll have to do to the other side of the colon. So of course, you'll have to divide 100 by 5. So that is how we get 1 in 20. And that is the simplest form of 5 to 100. And of course, 5 to 100 means every 100 part of a preparation is going to contain 5 parts of an ingredient. If I have 1 in 20 of a substance, in terms of ratio strength concentration, it means that I have 1 part of an ingredient that is a part of 20 parts of a substance or a preparation. Just as how percentage strength is written or expressed as weight in volume, volume in volume, weight in weight, is the same for ratio strength. Let's look at ratio strength in terms of weight in volume. This is also just similarly to the concentration, percentage concentration. It is the number of grams of a solid substance that will be found in a certain volume of preparation. The difference with ratio strength and percentage strength is that the volume may differ. It's not going to be 100% all the time. So for example, a preparation that has a ratio strength of 1 to 1,000 indicates that 1 gram of a solid substance would be dissolved in case of a solution or dispersed in case of a suspension and an emulsion in 100 ml of the liquid preparation. While percentage concentration is speaking to the amount per 100 ml all the time. Ratio strength, on the other hand, Can be 100 mil, it can be 1,000 mils, it can be 50 mils, whatever the case may be, it is dependent on the volume that is expressed in the ratio. And usually the second value or the second number is indicative of the number of volume or the number of milliliters. And in this case, the unit for weight and volume is going to be grams and mils. If we want to convert percentage strength to ratio strength, I think I missed something. Let me go back. Yes, I did. So that's weight in volume. Volume in volume is similar to concentration, as I said before, but it's going to be the number of milliliters of a liquid substance in the volume of a preparation. So 1 in 1,000, volume in volume represents 1 mil of a liquid substance dissolved or dispersed in 1,000 mils of a liquid substance. For, it's not written here, but for ratio strength for weight in weight is going to have the expression of a number of grams of a substance that would be contained in grams of a preparation. So for example, if I have the preparation that has a ratio strength of 1 in 1,000, weight in weight, that represents 1 gram of a substance that will be dispersed in 1,000 grams of a solid or semi-solid preparation. Now, the difference between ratio strength and percentage strength is that percentage strength deals with 100 parts. How much of the thing, how much of the ingredient is going to be contained in every 100 parts. Ratio strength deals with the amount of volume, the amount of grams that would be found in terms of weight in weight, the amount of grams in the grams of a substance. In terms of volume in volume, it is going to be in terms of mils in mils of a substance, and in terms of weight in volume is going to be grams in the volume or number of mils of a substance. It doesn't have to be 100 parts or 100 mils. It can be 20, it can be 50, whatever the volume or grams or weight, whatever the case may be. All right, so we can convert between the two expressions of concentration. Let's look at this, converting 20% weight in volume to ratio strength. We know that 20% means 20 parts out of 100. So 20 parts out of 100 can also be written as a ratio strength of 20 colon 100, which means 20 parts are found in 100 parts. 20 to 100 is a ratio strength concentration. However, we always write our ratio strength in the simplest form. Now, do you remember how we get the 20 to 100 in its simplest form? We need to make 20 be 1. In order for 20 to be 1, we need to divide by 20. 20 into 20 goes 1 time, right? So in order for our simplest form to have our 1 to the left-hand side of the column, we have to divide that number by itself. And 20 into 20 goes 1 time. So you don't leave it there. Whatever you do on one side of the colon, you have to do it on the other side of the colon. So you'd have to divide 100 by 20 and you get 5. So converting 20% weight in volume to ratio strength is simply just determining how many parts of the ingredient will be found in 100 parts. Because it's 20%, it's 20 to 100, and you simplify that to 1 in 5. So how do you convert ratio strength now to percentage strength? Rather simple, barely an inconvenience. Convert 1 in 5 weight in volume to percentage strength. We know that 1 in 5 means 1 gram in 5 mils. And how we know it's 5 mils? Because it says weight in volume. Did you see that? Since the percentage strength is the amount found in 100 parts, in this case 100 mil, if we know that 1 gram is contained in 5 mils, then we can determine how much of the drug or the ingredient will be contained in 100 mils, and that would have been 20. So 20 grams will be found in every 100 mils. And what's that in terms of percentage? Correct. 20% weight in volume. Very good. So let's look at some examples. Determine the total amount of benzoic acid that is contained in 225 mils benzoic acid solution of ratio strength 1 in 20 weight in volume. Express this ratio strength as a percentage. First, we're defining what the notation 1 in 20 weight in volume means. It means that an amount of the solid is going to be dissolved in an amount of liquid. In this case, 1 gram of benzoic acid is going to be contained in 20 mils of benzoic acid solution. Remember, 1 in 20, 1 part in 20, 1 gram in 20 mils because of the weight and volume notation. The next step is to determine the amount of benzoic acid that is contained in 1 mil. Then determine the amount that will be contained in 225 mils of solution. 1 gram is contained in 20 mils, so therefore each mil is going to contain 0.05 grams. If 0.05 grams is contained in 1 mil, then we can always determine how much would be in 225 mils, which is 11.25 grams. Now we need to express 1 in 20 weight in volume as a percentage strength. So 1 in 20 means 1 gram of benzoic acid containing in 20 mils of benzoic acid solution. So in order to express as a percentage, you must determine the amount that would be found in 100 mils of the benzoic acid solution. So if 1 gram is contained in 20 mils, then X is contained in 1 mils, which is found to be 0.05 grams. Then we determine how much will be in 100 mils, and that is 5% weight in volume. Of course, you don't have to go through all of that. You could just go straight to 1 gram is contained in 20 mils, then how much will be in 100. But the only way you would have known that is that you would have understood the concept of percentage strength, which means in every 100 parts. So you'd have to determine then how much of benzoic acid will be found in 100 parts of the benzoic acid solution. Let's look at example 2. Determine the total amount of salicylic acid that is contained in 30 grams of salicylic acid ointment of ratio strength 1 in 50 weight in weight. Express this ratio strength as a percentage. First step, determine what the notation 1 in 50 weight in weight signifies. From you say weight in weight, you know it's gram in gram, straight off. So this means that a solid is incorporated in a solid base. In this case, it's going to be a semi-solid because it's an ointment. So 1 gram of salicylic acid will be contained in 50 grams of salicylic acid ointment. And the next step now is to determine the amount of salicylic acid that will be contained in 30 grams of the ointment. Of course, you know that 1 gram is contained in 50 grams of the salicylic acid from the ratio strength signified there. You determine how much will be found in 1 gram, which is 0.02 grams. And then from that, you determine how much will be contained in 30 grams. As usual, you do not have to determine the unit. You could go straight to the 30 grams. So the next step is now to convert 1 in 50 weight in volume as a percentage strength. This means that 1 gram of the substance, in this case salicylic acid, is going to be in 50 grams of ointment. Of course, you need to determine the percentage strength. That means you need to find out how much will be in 100 grams. So you find the unit again, how much will be in 1 gram, and then you find out how much will be in 100 grams, which is 2 grams. And 2 grams of the salicylic acid will be found in every 100 grams of salicylic acid ointment, which means that the concentration would be 2% weight in weight. This is just saying what I said a while ago. All right. So now that we have done percentage strength, ratio strength, you should be able to convert and calculate between these two expressions of concentration. It shouldn't be a challenge now, because you know that percentage concentration speaks to out of 100 parts, while ratio strength speaks to the amount found in either volume or mass or mils or grams, right? Doesn't have to be 100. It can be 1 in 50 or 1 in 1,000 or 1 in 10, or you may even see it in 2 in 10. Might not be in the simplest form, and you may need to put it in the simplest form. So that should not be a problem. You just need to practice. So we're looking at milligram percent, and we're not going to stay long on this because it's fairly straightforward. It is speaking to the strength of a mass in a volume expressed as the number of grams per, the number of milligrams per 100 parts. And it's usually used to express the concentration of natural substances in your biological fluid. So while concentration, percentage concentration speaks to grams in volume, in terms of weight in volume, this is going to speak to milligrams per 100 mils. Hence the name milligram percent. So I don't want you to mix milligram percent with percentage concentration. Percentage concentration deals with grams per mil in terms of weight in volume. But milligram percent would suggest that it is speaking to the amount in weight per 100 mils, is speaking to milligram per 100 mils because of the nature of the natural substances found in our body. They are very small in terms of the amount. So expressing them in grams might be a little bit too laborious, so we need to express them in milligrams. Many times, often, it is expressed in terms of nanograms, etc. But milligram percent is often used. So if I have a 30 milligram percent, what does that mean? It means I have 30 milligrams of the substance contained in 100 ml of, say, body fluids, in urine or in blood or in plasma. Okay. Okay, so we're winding down and we are looking at the very last expression of concentration, which is parts per million and parts per billion. This may be defined as the number of parts of an agent or a substance that is found in either 1 million or 1 billion parts of a mixture. And in this case, the mixture could be drinking water, potable water. It usually deals with large volumes of mixture, usually, and small amounts of a substance. And usually they're looking at things like fluorine or fluoride ions in water, or chloride ions in water, etc. So for example, fluorinated drinking water often contains 1 part of fluorine per million parts of drinking water, and it is expressed numerically as 1 in 1 million parts of drinking water. The unit measure of weight is usually grams, and that of volume is usually the milliliter. Okay? So, express 5 parts per million of iron in water in percentage strength. So, we are going to apply the knowledge that we know. We know that 5 parts per million is indicative of 5 grams of the iron in 1 million parts of 1 million mils of water, right? So if you know that, you already have your percentage strength and ratio strength. The percentage strength you would have written right away, 5 parts to 1 million parts. But of course, if we're going to be writing that, it needs to be what? Simplified. So in order to simplify it, you're going to have to, I am going to ask you when I come in the next class. So you're going to simplify 5 to 1 billion parts in the simplest form in ratio strength. Now, if you're going to express this in percentage concentration, then you have to find out how much of the iron is going to be contained in every 100 mils of the water. So you know 5 grams are found in a million mils of water, so you're going to have to find out how much would be in 100 mils. And that is 0.0005 grams. And therefore, the percentage concentration is going to be 0.0005%. Okay, I had it here. So you got away. 5 parts per billion is expressed as 5 parts in 1 million parts. Expressed as ratio is 5 to 1 million. Therefore, in its simplest form, it is 1 in 200,000. And then I'm going to ask, somebody's going to tell me how they got, or how I got 1 in 200,000, and if that is correct. Okay, so let's look at an example. The concentration of a drug substance in an animal feed is 12.5 parts per million. How many milligrams of the drug should be used in preparing 5 kg? First thing we write is 12.5 parts per million of the drug is expressed as 12.5 parts in every 1 million parts of the feed. In this case, it's going to be 12.5 grams contained in 1 million grams of feed. But they want to find out how many milligrams will be found in 5 kg. 5 kg is equivalent to 5,000 grams. You can't just put 5 kg there because everything, all the units are in grams. So we have to change the 5 kg to 5,000 grams and then determine how many milligrams would be found in that. Okay? We found that 0.0625 grams are found in every 5,000 grams of the feed. But the question asks for milligrams, so therefore we just have to change the grams to milligrams, and we got 62.5 milligrams. So we have come to the end of the lesson, and that we had learned that there are different expressions for concentration applicable to pharmaceutical calculations, and these include 1, percentage strength, which speaks to the amount per 100 parts, and that amount can be in terms of weight in volume, amount of grams in 100 mils, in terms of volume in volume, the amount of mils per 100 mils, and in terms of weight in weight, it can be grams in every 100 grams of a substance. We also learned of ratio strength. Ratio strength is really the amount to the amount or in the amount of total parts. So it can be expressed in terms of weight in volume, where it is the amount in grams in a certain volume of substance. Doesn't have to be 100, it can be 20 mils, 100 mils, 50 million mils, 10 mils, 1 mil, whatever the case may be. But in terms of weight in volume, it is amount of grams per volume. And it is written in a ratio form, say 20 to 100, but we often like to express it in its simplest form, and 20 to 100 would be 1 to, which is colon to 5, which indicates that 5 parts are contained in, say, 5 mils in terms of weight and volume. Also expressed ratio strength as volume in volume, which is the number of mils in an amount of mils, or volume of a substance in mils. And it can also be expressed in weight, where it is the number of grams in the amount of grams of a substance. We also saw that we could express concentration in terms of milligram percent, especially for endogenous substances in the body. And milligram percent, as it suggests, is the amount of substance in milligrams that's found in every 100 ml of body fluids. And we also learned of parts per million and parts per billion. parts per million indicates the amount in grams per 100 million, I'm sorry, amount of parts in terms of grams in 1 million mils, or it could be expressed as the amount of parts in grams in 1 million parts in terms of grams. So it could be in volume, or it could be weight in volume, or volume in volume. Okay, and it also could be weight in weight. Right? Just as how we had seen with the antibiotic in the feed. So it could be the same expressions that we would have seen with ratio strength and percentage strength in terms of the notation: weight in weight, volume in volume, and weight in volume. All right. So these are all the expressions that you need to know in terms of pharmaceutical calculations. I'm very, very happy that we were able to go through this lesson, because this is going to assist us now with even much heavier stuff when we go to dilution and fortification of substances, and you need to know about concentration to proceed there. So I'm hoping to give you some exercises after you have reviewed these videos to test your knowledge to see how well you're doing. Please don't forget to try your hands at the questions in the book, because when I come to the next class, we'll be looking at those questions and working them together. Thank you so much for your attention, and we will meet again next time.